everyone. We're looking at question number 6 of summer 2014, paper 439702. The question reads, an uncharged capacitor is connected in series with battery, a switch and a resistor as shown in figure 6.1. We have the capacitor here, the battery and the resistor. The battery has EMF 9 volts and negligible internal resistance. The capacitance of the capacitor is 4700 microfarads. The switch is closed at time 0 during the time interval t0 to t4 seconds. The charge passing through the resistance is 22 millicoulomb. Calculate the energy transfer in the battery during the time interval 4 seconds. Now, most of the students, what they would do is they have learned these two formulas for finding energy in capacitance, that is E is equals to 1 by 2 QV or E equals 1 by 2 CV square. But the catch here is that they are asking for the energy transfer in the battery. So for that, whenever we have energies related to battery, there is one thing that we understand, what we read is in the definition of potential difference. Potential difference denoted by V, it is the work done or energy transferred in driving a unit positive charge around the complete circuit. So I will say it is the work done or energy transferred in driving a unit positive charge around the complete circuit. Now the work done is equal to the energy transferred, so I can make this as my subject and I can say that work done is equals to V into Q, because we're talking about the battery and not the capacitor. So when we do that, we have our EMF that is given to us as 9 volts. Multiplied by the charge which is given to us as 22 millicoulomb. So we will be writing as 22 into 10 raised to the power minus 3. And when you solve this, the energy transfer that you get is 0.20 joules. Moving on towards the second part, determine for the capacitor. Now everything that we will be doing is for the capacitor, so if it's energy then you can apply those formulas and so on. Number 1, the potential difference V across the capacitor. Pretty simple. You need to have a very good understanding of the formulas of the capacitor. What do we mean by capacitance? The capacitance itself can be defined as C equals Q over V, charge over potential difference. So we have to find V. We can make this as a subject of our equation and we will get V equals Q over C. And we have our charge as 22 millicoulomb. We can write that as V equals 22 into 10 raised to the power minus 3 over the capacitance, which is given to us as 4700 mega, which we can write as 4700 into 10 raised to the power minus 6. And plug this in and the value you get is 4.7. And that is your answer. Moving on towards the second part, the energy stored. Now we're talking about the energy stored in the capacitor. So we do know, we have talked about this graph of capacitance. We do know capacitance is Q over V, right? So if we plot this graph of V against Q or Q against V, we will get a straight line like this. And from there, when we talk about the area under the graph, we can say this area under the graph can be, it's like a triangle, so it is forming 1 by 2 QV. So area of the triangle formed. So we're going to find out the area of this portion, which is 1 by 2 into Q into V. So this is how we derive the formula of the energy. Now it can be 1 by 2 QV, or what you can say to make it, we know Q is equals to CV. If we make Q as a subject, we will get CV. So I can replace Q with CV and I get CV into V, which is CV square. So these two are the formulas that I can use for energy. It's up to me. It actually depends on whatever they've given to us in the question. If I were to use this one, I can get 0.5, which is 1 by 2, 0.5 into Q, which is given to us as 22 into 10 raised to the power minus 3, 22 into 10 raised to the power minus 3, into V, which was given to us as 4.7, because that's something we found out here. The reason why we will not be using this V as 9 volt, because this V is of the battery. We're talking about the capacitance. Everything we write in this has to be related to the capacitance, and this potential difference is for the capacitance, so we will be using 4.7. And when you solve this, you get 0.0517, so you can just write 5.1 into 10 raised to the power minus 2. And now the B part that says suggest why your answers in A1 and A2 part 2 are different. A2 part 2 talked about the energy stored in the capacitor. This talked about the energy stored in the battery. It's 0.2, that is 0.051. So we can see that the value in the battery is far greater than that. So we can obviously say that while it traveled from the battery all the way to the capacitor, there has been a decrease, which indicates energy lost. So that energy can be lost as thermal energy. So best way to write this answer is the value of energy decreased, indicating the energy lost as thermal energy. In, you can talk about the battery, but they have talked about how battery has negligible resistance, so we can talk about the energy lost, heat energy lost in the resistor or wires, anything. As thermal energy in resistor or wires, because usually a decrease in this energy tells us that there has been a loss of energy. So you just need to elaborate on that a little, that energy has been lost as thermal energy in resistors or whatever is given to you in the circuit. And this is it for B part as well, and for question number 6.